My name is Sean. Today I will be conducting an experiment on solids, liquids, and gas. Now, gas assumes the shape and volume of its container and the particles can move past one another. It has lots of free space between its particles, so that means that the particles can move past one another. It assumes the shape of the container, but the particles can still move or slide past one another. Liquid has little free space between particles, but the particles can still move or slide past one another. Solid retains a fixed volume or shape of the particles and stay locked into place. Solid also has a little free space between particles, but since it is rigid, the particles cannot move or slide past one another. So gases, liquids, and solids are all made up of atoms, molecules, and ions. The behaviors of these particles are different in these phases. So right here, we have oxygen, atoms, and molecules. This is just a model to show you how this looks of atoms, molecules, and oxygen. Right here, I have clay. This represents my solid, and right here I have my cutter. I will be cutting half of the clay, making a piece of the clay. See, I have my piece. Then I'll grab my tube, get some water from my flask, pour little drips on top of my clay, and right here you will see that some of the water is up there and no water is going through it or over it. So right here I have my baking soda, and baking soda are in 4 parts of my trays, and I will put liquid in there. This is 4 of my liquids. This is water, this is sodium, this is calcium acetate, and this is vinegar. Right now I will be putting water with 4 drops into the baking soda. See what the reaction will be. See, there's kind of like no reaction because the water is so pure that there's barely any reaction. We're gonna get a toothpick, move it around. It's kind of wet, so the baking soda barely had a reaction with the water. So now I'll get my sodium, put a little bit of drops into the baking soda. Now you see that the baking soda with the sodium barely had any reaction. Kind of looks like the water, how it's like still wet with the baking soda. With my toothpick barely moving around, seems like it's so wet. Now I'll get my calcium acetate, put a little bit of drops with the baking soda. Right there you see that there's barely any reaction. I'll grab my toothpick. See that it's kind of foaming up, how it's bubbling. Doesn't look very watery as the sodium and water. Yep, put that down. And now I'm got my vinegar. Put a couple drops with the baking soda. Now you see how that foamed up? Kind of like the calcium, but better. Like better reaction than it. All foaming up and have a reaction with the baking soda. Now it's all just wet, but still has a bubbly reaction with the vinegar. Okay, so now we're moving on to gas, and as you can see, I have my balloon, aka glove for those some political correct people, and that my balloon has air in it or gas. And when you put gas or air in something, that it assumes its shape. So you see how the fingers are blown up. So if heat gets onto the balloon, it expands. If you put cold onto it, it shrinks. So in conclusions, this experiment was about solids, liquids, and gas. Now, for the first part, for solid, we talked about clay and how the liquid's over it, how nothing can go through it or over it. And for liquid, we talked about how water, sodium, or calcium, or vinegar can go with the baking soda. And for the gas, we talked about how air in the balloon or in the glove can expand if it hits heat or shrink if it hits cold. Now, this has been an experiment with Sean, and I'll see you guys later.